All right. Good morning. So we're on lesson 3 in module 3, and we're going to be continuing to expand on what you've learned from lessons 1 and 2. So what you'll need before we get started is your math book. Obviously, we're going to go to lesson 3. You need your personal whiteboard and a dry erase marker. If you don't have those things yet, please quietly get up and go get them without bothering anybody. All right. Pause the video if you need to get those. Great. So today we're just building on what we've already learned about perimeter and area. We are going to talk more about what it means when something is sometimes larger than another thing, and we're going to go straight to the problem set. That's where all of this learning is going to take place. So find the problem set, and this is problem 1. Because this is a video, you can pause me at any time. You can go back, you can rewatch, you can re-listen. Okay. So I always say, if we're not really sure what to do, we have to be able to write something down and get some sort of understanding about what's going on in the problem. In problem 1, we have a rectangular projection screen in a school auditorium is 5 times as long and 5 times as wide as the screen in the library. In our gym or cafeteria, there is a big projection screen, and it's much larger than the screen in class. The screen in the library is 4 feet long with a perimeter of 14 feet. So on your whiteboard, I want you to just draw a rectangle, and we're going to make the top side 4 feet, and we know that the perimeter is 14 feet. So on your whiteboard, I just want you to write the things that we know. This is all we know right now. We have a rectangular screen. It's 4 feet wide, or 4 feet long, whatever. And the perimeter is 14 feet, so we'll just get down those things. We know that if we're dealing with a rectangle, the opposite sides are the same length. So if the top is 4 feet, the bottom is 4 feet. 4 feet. And we know that the whole outside, the perimeter, is 14 feet. Okay, so that's adding. Let's add up. 4 plus 4 is 8. 14 minus 8 means I have 6 feet left for both sides. Well, 6 feet. I have to split that into 2 sides. Half of 6 is 3, and the other half is 3. So I know that that my perimeter is 14 feet, and these are the dimensions of the screen in the library. What I also know is that the screen in the auditorium is 5 times bigger. 5 times bigger. It's much larger. And it doesn't mean that, well, if this one's 4 and that one says 5 times bigger, then this one's got to be 5. It's not what that means. If the auditorium screen were just 5, it would say it's 1 foot bigger, not 5 times bigger. When we say 5 times, it's 4 times 5. 4 times 5. What that could look like on your paper, we can section. So if we know that one section is 4 feet, let's draw 5 sections on top. And what that means, I'm going to show you in just 1 second. Just the top, we're going to match these up. So just the top is 4 feet in one section, just like the top is 4 feet here. And it's 5 times bigger. So I've got 5 sections, and each section is 4 feet. We can add those totals up. So 4 plus 4 plus 4 plus 4 plus 4. 4 plus 4 plus 4 plus 4 plus 4 is 8, 12, 16, 20. So I know this whole side, and I'm going to show you in just 1 second what I did, is 20 feet. And if you are thinking about it, 4 times 5 is 20. So on my whiteboard, I'm just showing the whole top of the auditorium projector. Here's our library projector. It's just 4 feet. This one is 4 feet times 5. If I know that the side is 3, hold on, I'm trying to figure out how to section this. So I still want 5 sections. Each of them on the side is 3 feet. So on the side, I still have 5 sections because it's 5 times as long and 5 times as wide, but each section is only worth 3 feet. If I add up my 3's, 3, 6, 9, 12, 15, this whole side is 15 feet. It's 15 feet. 3 times 5 is 15. If I know one side is 15, the opposite side is 15. If I know one side is 20, the opposite side is 20. Again, if you need to pause and rewind and rewatch and redraw, this is what you should end up with. 2 rectangles. One is the original. The next one is 5 times as big. 5 times bigger. We want to know, what is the perimeter of the screen in the auditorium? So that's our big screen, the screen in the auditorium. So perimeter is adding. Let's add up all the sides. 20 plus 20 is 40. 15 plus 15 is 30. 30 plus 40 is 70. The perimeter is 70 feet. P equals 70 feet. P for perimeter equals 70 feet. Please don't just write 70 on your page. 70 is not what I'm looking for. 70 doesn't answer the question. Perimeter, or P, is 70 feet is what I'm looking for. We can't just put 70 because that doesn't say anything. You have to be able to explain what it is you're doing. If you're just going to be lazy and just write 70, don't even bother doing it. Okay, you got to do it. Just do it right. Why do it wrong when you can just do it right the first time? Perimeter equals 70 feet. You may erase or go back and rewatch or move on to problem 2. The width of David's rectangular tent is 5 feet. Alright, so here's what we know. We have a rectangle. And one side is 5 feet. This is all we know just from reading the first sentence. A rectangle, one side is 5 feet. The length is twice the size of the width. Okay, well, if we're not sure what a length or a width is, here's my 5-foot side. The opposite side is also, hopefully you know, if those two sides are taken care of, then my length is the other side. Width, length. Width, length. Width, length. The length is twice the size of the width. Okay, well, the width is 5 feet. The width is 5 feet. Okay, if the width is 5 feet, then the length is 5 feet 2 times. 5 feet and 5 feet. Okay, so add them up. 5 plus 5 is 10 total feet. 10 total feet. 10 feet for the length. 10 feet. If this side is 10 feet, then this side is, you got it, 10 feet. Alright, here's what we know. This is all we know, just from the first 2 sentences. Okay, here we go. Let's keep reading, because I gotta believe this isn't all that we need to do, because we've only read 2 sentences. But in 2 sentences, we know all the length of the sides. Okay, let's keep reading. David's rectangular air mattress, oh boy, measures 3 feet by 6 feet. If David puts the air mattress in the tent, how many square feet of floor space will be available for the rest of his things? Okay, well, geez. How can we do this to make this make the most sense? Alright, so here's what we know. He's got a tent, we know the dimensions. He's got an air mattress, we know the dimensions. It's 6 feet long by 3 feet wide. Okay, so what I want to do is I'm just going to make a section that's 3 feet wide. So I want to just kind of section this off. If we know this is 5 feet, then every section equals 1 foot. Every mark I made equals 1 foot. So let's make it go up 3 feet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we'll count over 1, 2, 3, 4, 5, 6. We'll count over 6 feet and we'll kind of draw that mattress. There's his mattress. It takes up this much space. Okay. And this is 3 feet by 6 feet. It's 3 feet by 6 feet. Okay, so here's what we actually need to know. How many square feet of floor space will be available for the rest of his things? Okay, so like picture this tent. It's an open rectangle. And then you blow up your air mattress and it takes up space on the floor. So that space on the floor is no longer available for you to walk around or sit on. But you get to sleep on your air mattress in that space. So we need to do two things. We need to find the whole area of the tent and the area of the mattress. Then subtract the mattress from the whole area. Alright. If area equals length times width, if area equals length times width, let's find the area of the whole tent first. The length is 10. The length is 10. The width is 5. The length is 10 and the width is 5. 10 times 5. Okay, how are we going to do this? Are we going to count it by 10s or 5s? Let's go by 10s. 10, 20, 30, 40, 50. 10 times 5 is 50 feet. The area of the tent is 50 feet. Let's find the area of the mattress. The length is 6. The width is 3. The area of the mattress is 6 times 3. Let's count up by 3s. 3, 6, 9, 12, 15, 18. The area of the mattress is 18 feet. Okay, so again, we want to know the rest of the space in the tent without the mattress. So that means we have to take our 50 feet from the tent and we have to subtract 18 feet from the mattress, and we're just going to set up a standard algorithm for subtraction. Borrow from the 5, make it a 4, make the 0 a 10. 10 minus 8 is 2, 4 minus 1 is 3. So David will have 32 feet of space left in the tent. Please do not write 32 feet. When you write your answer, it needs to be a complete sentence. There will be 32 feet of space left in the tent. There will be 32 feet of space left in the tent. Pause now if you need to get this down. Alright, I'm erasing, moving on. Okay, if you feel you're good, if you feel you don't need me anymore, you may stop watching me and continue on with your problem set. If you feel like you need to do a couple more, keep on watching. We only have 2 more left. Okay, problem 3. Again, pause, rewind, go back and rewatch if you need to. Jackson's rectangular bedroom has an area of 90 feet. Okay, cool. We can start there. Rectangular bedroom has an area of 90 feet. This is what we know. The area of his bedroom is 9 times bigger than his closet. So here's his bedroom. Here's his closet. Whoa, jeez. It's a little guy. It's just a little tiny closet. The bedroom is 10 times bigger than the closet. The area of the bedroom is 90 square feet. The closet is 2 feet wide. The closet is 2 feet wide. What is the closet's length? All right. So, here's what we know. Here's what we know. Geez, there's not a lot of numbers here, is there? Okay, so let's think about this. If the room, hold on, real 1 second. All right, Miss Lewis just stopped by for a second. Okay, so here's what we know. The whole area of the bedroom is 90 square feet. The closet is 10 times less. All right, so if our whole area is 90 feet, let's think about what 10 times less is. All right, so this is going to be a little bit complicated, but something times 10 equals 90. Something times 10. Something times 10. Okay, so something times 10 equals 90 feet. All right, so let's just count up by tens till we get to 90. 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, that was 5 plus 4, so that's a 9. I know that 10 times 9 equals 90 feet. So that tells me that that our closet is 10 feet. 10 feet. Okay, and I just want to make sure that we understand this. So if the area is 90 square feet and it's 9 times bigger than the closet has to be 10 square feet. It's 9 times bigger, because 10 times 9 equals 90. So the closet actually equals 10 feet for the area. Okay, so here's the closet. The area equals 10 feet. The area equals 10 feet. I know that one side of the closet is 2 feet, and we just need to multiply it by something that gets us 10 feet, because we want to find the other side of the closet. Alright, so let's count it by 2s until we get to 10. 2, 4, 6, 8, 10. 2 times 5 gets us 10 feet. So that means that this side of the closet is 5 feet. 5 feet. That was a complicated problem. We had to work backwards from one section to find a completely different section. And this was a complicated problem, and there was a lot of thinking involved in here. But you have to be able to start somewhere. So anything you can get down first, any picture that you can draw, any way you can make sense of it, start there with math, with complicated math problems, or with easy math problems too. Because sometimes it might seem easy until we get into it, and then we realize it's not that easy. Alright, if you need to rewatch, pause and go back. Otherwise, here's the last question on your problem set. The length of a rectangular deck is 4 times its width. Alright, so I have a width and I have a length. I have a width and I have a length. My width and my length. Width and length. If the deck's perimeter is 30 feet, what is the deck's area? Okay, so I know that my width is a number. I don't know what it is yet, but I know that it takes 4 widths to make my length. So my width is going to equal a number. My length is going to be 4 of those numbers put together. What I know is the total perimeter equals 30 feet. The total perimeter equals 30 feet. Oops. Okay, so we can do this a couple ways. We can just start putting in numbers for the width and then other numbers for length and then add them up till we get to 30. Okay, so let's try that first. Let's try if the width equals 1, then we know that each of these sections will also equal 1. So 1, 2, 3, 4. Okay, if that's true, then this side's 4, and this side's 4, and that's 8. And this side's 1, and that side's 1, and that would equal 10. That's not enough. If that equals 10 though, and my number is 30, which is a multiple of 10, how many 10s does it take to make 30? Well, 10, 20, 30. It takes 3. Let's try 3. Maybe this side could equal 3. Excuse me. And if this side equals 3, then we know this side equals 3. And if we know that the length is just 4 times more, let's make all these sections equal 3 as well. There's 3, 6, 9, 12. The whole length equals 12. That means this whole length equals 12. Let's add them up. 12 plus 12, 24. 25, 26, 27, 28, 29. Oh my gosh, it's 30. Would you look at that? Look at that. All we had to do was start somewhere. We figured it out. We just have to start somewhere. So here's the question. If the deck's perimeter is 30, which we know, what is the area? Area equals length times width. Yeah. The length is 3. The width is 12. The area is 3 times 12. Area equals, oh geez, how am I going to do this? Should I count it by 3s or should I count it by 12s? Do it however makes sense to you. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, there's 10, 33, 36, there's 12. I know that the area is 36 feet. The area equals 36 feet. Okay, anything else we need to do there? Wonderful. This was the entire problem set. If you get to a point where, if you're working on the homework, which you're going to do right now, you're not really sure what to do, come back to the video, rewatch one that is similar to it, and try to figure it out. If at that point you still don't know, raise your hand, come see me, and I'll help you out. This concept, I'm pretty confident that we all know how to find area and perimeter if we have the right numbers. It's finding those right numbers that's the difficult part. If however you feel about this is where you're at, if you feel like you're good to go, awesome. If you still feel like you need some more help, then we just keep working on it. All right. Good luck. Peace out.